Welcome to myprojectbazaar.com.
Now we are going to discuss about our product title is Circuit Topology and Operation of a Step-Up Multi-Level Inverter with a single DC source. Let's we see our product abstract. In our process we are using the inverting process. The inverting process we are using the switching capacitor topology. We have designed the control of the charging as well as the discharging the process capacitor predetermine the time interval. The most important of attributes of the multi-stage structure is the multiple charging capacities and the capacitors each stage compared with this previous stage, which can ultimately increase the output voltage of the low input DC voltage source. The difference combination of these capacitors will be discharged across the load and generate the high level stretches. The AC voltage waveform we get the last output of the high number of switching stage provides different path of capacitors. To achieve a self-balancing capacity and the low switching frequency and elimination of transformer are among the advantages of the proposed on our process. The compared with our topology, the number of the semiconductor device, the capacitors also reduced largely. The simulation result we can get the 38 switches and the loading switching also. We are using the 42 switching levels. We inverting the process. The multi-level inverters has a neutral point of the clamp like flying capacitors use different type of capacitors and switches split the input voltage to small voltage level. The combination of this capacitor generate the multi-level voltage waveform based switching patterns. These topologies suffer from the capacitor voltage unbalancing, which may need additional circuits for balancing purpose. Other topologies such as capacitor hybrid requirement stage of DC source, which can increase the volume of the circuit and transformably widely using the many applications such as electrical vehicles, renewable energy. The boost low energy of low input voltage which can be lead size of switching capacitors. The inverting introduced the new alternative of step-up DC voltage source. Main application of such converters, the main category of medium power range applications and high level power range applications. Let me see our process flow diagram. In our process we have designing the simulating tool using the MATLAB software, and then first we are giving the source. The structure is made up the three models. The model 1 is the conventional full bridge circuit whose switches are utilized to generate the maximum and the minimum voltage levels in the line to line waveform. And second model is for composed the three bidirectional switches in the which each and every each phase of the process we have using the each switch function the normal mode and the sense of the exclusively the employs the particular phase. And third model of the compares the string of bidirectional switches which are connected to DC source. The switches are made to operate the optimized mode. The way of the operations each switching is divided among the three phase, and then we connecting the inverter. The inverter has the main of switches and diodes. Mainly we have using the diodes and switches for IGBT. So we have using the 42 switches like diodes, IGBT diodes, and then 38 switches have using the main blocks, and the last 4 switch and diodes for using the single level of load. The in this our process we are using the three stages of configuration is presented in the process, and the inverter 40 switches is which three bidirectional switches are used in the model 3 to produce the 9 voltage level to line voltage waveform as following the amplitude for combining the switches and diodes for switch type of MOSFET, IGBT and diode. We are mainly focused on the process switches and combination of diodes for IGBT diodes, and we connected to the main for pulse generator. So we are using the PWM 3 level base for the SVM based. The various modulations of techniques have been used with the multi-level inverters. These include those of low frequency of the based methods such as selective harmonics, eliminations, and space vector control. Other the process high switching frequency such as multi-carrier pulse width modulations. In this work, one of the most preferred PWM strategies now the space vector PWM is aimed to provide these sections presented this descriptions about the probably the three-level inverters process, and the last we are using the analyzing the process. Analyzing the process, we have completed after completing designing work where simulation result is carried out of the first step to the performance of the proposed multi-level inverters. For this purpose, a simulation model of the three-level inverters is developed by MATLAB Simulink environment. We got input we give the input for the 24 volt and the DC voltage, and we got the output for the same level of the input, but we get the AC voltage source. Let me see our process running procedure. We have designing the multi-level bidirectional inverters using MATLAB software and Simulink tool 2013 A versions. We have completed this designing, and we are going to give the input for the 24 volt DC voltage supplies, and we got the output for AC power supply. At the same time, SVM based PWM pulse width modulations, we get the switching generation pulse generations. And then now we going to the running the process. After designing the finished, we go into the running the process, and we get the graphical output for here the scope functions. After finishing the running the process, we got the output for this is input scope function for we give the input for 100 voltage DC voltage. At the same time, we got the output for the level 100 voltage DC for AC supply voltages. So we get the AC power supply for AC power supply, and the same time we give the switching pulse also. So this is for the pulse generation for EWM, and is being based the process. Or this is a switching pulse for the 38 switching for pulse generations, 4 switches for the load connections. So thank you for watching our video.